In this problem, we have a spring. The spring constant is K equals 75 Newton per meters, and we're compressing that spring 0.6 meters. So this distance right here is 0.6 meters, and we're shooting a 3 kilogram ball. So this ball right here is 0.3 kilograms, and the ball is shooting out and over a small dip, so that this distance ends up being 5 meters before it hits the ground. So the first thing we need to know is what is the initial mechanical energy of the ball, using the final position as the end point. So because this ball has a height and it was also compressed by a spring, our total energy, so you can call this E total, E initial, whatever you want to call it, is this, is the sum of the spring potential energy and the sum of his gravitational potential energy, or his height. So the spring potential energy is this 1/2 kx squared, and the gravitational potential energy is this mgy. So now I'm going to write an A here so we know that's part A. Now we can put in our numbers, so we'll put in that 75. X is the amount that spring was compressed. So that's going to be that 0.6. And this is going to be the mass of our ball. Gravity, which is 9.8. And then our height, which was 5. Okay. So now on your test, it goes straight to the final answer, but I'm going to do them separately for you guys. So we'll do 6 times 6, 0.6 times 75 times 0.5. So that gives you 13.5. I like to do an extra step here. I know it takes an extra minute, but I feel like it keeps me from making a mistake. And then it's going to give you 28.2 joules. Now let's go to part B. Part B is asking what's the final mechanical energy of the ball if it hits the ground. So, due to the law of conservation of energy, we know that our initial energy is equal to our final energy. So that means, our initial energy was 28.2. So our final energy is going to be 28.2 joules as well. Okay, so that one's kind of easy, luckily. Now let's do one more. I'm going to try and pick a color that I haven't already used. Let's try this. Okay, now let's do part C. Part C is asking with what velocity does the ball hit the ground. So when it hits the ground, we're going to have that, that's that final energy, but when it hits the ground, it's not going to have that kinetic anymore. It's not going to have the potential because it's going to have a height of 0, and we're not really going to need to mess with that spring energy, so we're just going to have kinetic. So it's just going to be that. And so then we can take, we can put our 28.2 here, and then we'll have 1/2 times 0.3 times v squared. So 1/2 of 0.3 is 0.15. I'm going to divide both sides by 0.15. Let me plug this in my calculator. That's going to give me 188. Which is going to give me 13.7 meters per second is our velocity. So that's how you solve these like spring / energy / conservation of energy problems. They are, a little bit more difficult because you have your potential energy, your kinetic energy, and then you have that potential energy of that spring as well. So you have to take that into consideration.